Have you ever wished you could just take one of these super powerful AIs and teach it to be an expert in something you really care about? Well, that's exactly what we're diving into today, fine-tuning. But how do you create a custom-built AI genius without needing a massive budget? Let's get into it.
It's a really exciting idea, isn't it? I mean, imagine teaching an AI to be an expert in your specific world. Maybe a legal assistant that knows your firm's entire case history, inside and out. Or maybe a creative partner that can write in your unique style instantly. The possibilities are just about endless.
But here's the thing. There's always been a catch. For the longest time, customizing these massive AI models was kind of like trying to build a rocket in your garage. It was something only the huge players with super deep pockets and, months to spare could even think about trying. And just to give you a sense of the scale we're talking about, fully fine-tuning a large model could easily set you back $500,000 just in computing costs. That is a massive number, and it's a huge reason why this has been out of reach for so many people.
And it's not just the money. Can you imagine tying up a super powerful computer for 4 straight months? That's the kind of time commitment we're talking about. This combo of cost and time has been the biggest roadblock. Until now.
So you might be thinking, with all that cost and all that effort, why would you even want to fine-tune an AI in the first place? What's the big payoff? Well, let's dig right into that.
Okay, think of it like this. You've got a world-class chef who already knows how to cook basically everything. You wouldn't try to teach them the fundamentals of cooking from scratch just to make your grandma's secret lasagna recipe, right? No way. You just give them the recipe and let them adapt. That's fine-tuning. You take an AI that's already a generalist and give it a very specific, specialized skill.
So when is fine-tuning actually the right call? Well, it's perfect if you need a really consistent style or tone, or when you're dealing with very specific industry jargon that a general model just wouldn't get. It's also great when you need super fast responses. But, and this is the key, you need good data to teach it with. We're talking at least 1,000 high-quality examples to get the job done right.
Okay, so we've laid out the problem. Now let's talk about the solution. And this is where things get really, really interesting. There's a new set of techniques that are completely changing the game, making all this stuff accessible to pretty much everyone.
The big idea is called parameter-efficient fine-tuning, or PEFT for short, and the concept is genius. Instead of trying to update all, say, 70 billion parts of the AI's brain, you just freeze most of it, and you only train a tiny targeted section. It's so much smarter. And the absolute star of this new, efficient approach is a technique called LoRA. It stands for low-rank adaptation, and honestly, it's the real hero of this story. This is the thing that just blew the doors wide open for everybody.
I mean, just look at this difference. It's staggering. With the old method, you're chugging away updating 70 times billion different numbers. With LoRA, you're updating less than 0.1% of that. It's a total and complete game changer for efficiency.
So how does this little magic trick work? Well, imagine an AI's knowledge is like a giant, super detailed map. Instead of having to redraw the entire map just to add one new neighborhood, LoRA just leaves the original map alone. Instead, it creates a small, transparent overlay with only the new information. You only have to draw on that tiny little overlay.
To really drive home how dramatic this is, let's use a simpler example. Okay, imagine we've got a part of a model with 1 million parameters that we want to update. So using the old full fine-tuning method, you'd have to painstakingly update all 1 million of those numbers. But with the cleverness of LoRA, the number you actually have to train is just 6,000. That's it. From 1 million down to 6,000. That right there is the difference between needing a dedicated supercomputer for weeks and being able to do this on a decent gaming computer in a couple of hours. It's incredible.
Okay, so you've used LoRA, you've trained your model in record time, you're all done, right? Well, not even close. This is where a lot of projects actually go wrong, because the technical training, that turns out to be the easy part. This quote really says it all. The training is just the beginning. The truly difficult, and frankly, the most important part of the job is rigorously checking if your new specialized model is actually any good.
And this breakdown is pretty shocking, isn't it? The actual technical setup, the part we just got all excited about, is only about 5% of the total work. The vast majority of your time, a whopping 80%, is spent just preparing good data, and the rest is spent building the tests to prove your model actually works.
So how do you build a model that you can actually trust? Well, it all comes down to choosing the right ways to measure its success. And that means looking way beyond simple automated scores.
You really need two kinds of tests. You've got your automated scores, and they're great for a quick check to see if you're on the right track. But the most important tests, those are the ones that need a human touch. Does the AI's response actually make sense? Is it factually accurate? Is it safe? That's what really defines the user experience.
Finally, let's just run through a few common mistakes to avoid. Knowing these things ahead of time can save you a ton of headaches and frustration down the line.
Okay, the biggest trap is saving all your testing for the very end. You've got to test as you go, and don't get too obsessed with just one spore. An AI might ace a benchmark test but still be pretty useless in the real world. You have to test it with the kinds of messy, unpredictable stuff that real users are going to throw at it.
So if you remember just one thing, let it be this. Fine-tuning gives you the power to create a specialist AI. New techniques like LoRa give you access to that power, but it's the hard work of evaluation that gives you the trust to actually use it. Power, access, and trust. That's the recipe for a successful project.
So, the barriers have basically fallen. The tools are here. The ability to create a highly specialized AI assistant is more accessible than it has ever been before. So really the only question left is, what are you going to build?